Good afternoon, everybody. I am Dr.A.M.Shanawaz from Department of Mechanical and Automation Engineering. Today, I am going to discuss about the forging methods, hot metal work methods in the production technology. One topic. So, in the bulk deformation process, it comes under production technology. So here, the deforming there is deforming process. Make use of what is deforming process? So make use of suitable stresses like compression, tension, shear, or combined stresses to cause a plastic deformation of the material to produce record shapes without changing its mass or material. So we are not losing the material, we are changing the material to the finished product. So there are a number of processes are there. There's forging, extrusion, rolling, sheet metal working, explosive forming, and thread tooling. It comes under the deforming process. Then what is the purpose of the mechanical working, metal mechanical work? That is to reduce the original block or ingot which is received from the foundry shop to the finished project, to improve the mechanical properties of the metal by refinement of the grind structure. Because when the workpiece comes from the forging foundry shop, the grind structure may varies. So we have to refine it. When we refine it, its strength, mechanical properties will increase. So one of the purpose of mechanical work is to improve the mechanical properties. Then we can divide it into two sections, hot working and cold working. What is meant by hot working? Working the workpiece above the recrystallization temperature. That is, we have to heat the workpiece above the recrystallization temperature, but below the melting point. Every object, every component, every metal has some melting point and recrystallization temperature. It varies, depends upon the material. So when we heat above the recrystallization temperature and when we work on it, it is called hot working. When we work the component below the recrystallization temperature, that is called cold working. So in this figure shows the hot working metal. The metal is heated above the recrystallization temperature, and when it is comes when it is worked between two rollers, the metal is plastically deforms and elongates. Elongates means the coarse grind also elongates. The recrystallization equiaxed grinds are obtained. Growth of a new grinds will be obtained. So this shows the elongation of the material, elongation of the grinds. The metal extends, elongates, as well as the grain also elongates. New crystals are formed. In the hot working, we are going to discuss about the hot working at present. There are a number of working are there: rolling, forging, extrusion, piercing, and drawing, cupping, and spinning. So many operations are there. So today we are going to discuss about the rolling operation. So before that, what are the advantages of hot working? That is, working is done above the recrystallization temperature, so the refinement of the grind occurs. The porosity of the metal is eliminated. Some of the raw materials, there is a porosity, inclusions, then impurities may be available. So in this case, the porosity of the metal is eliminated. Then uniformity and directional property is improved. Mechanical properties such as toughness, ductility, elongation, reduction in area are improved. Then power required to finish the part is less. It is quick process, rapid and economical one. Then some of the disadvantages are also available for hot working. That is rapid oxidation, because when it is open to the air, the scaling formation may be available at high temperature. So due to that, the poor surface is we obtain a poor surface, we have to correct it, we have to secondary operations are required. The close tolerance cannot be maintained, because because of the oxidation, then deformation on the surfaces, the close tolerance cannot be maintained. The tooling and handling costs are high because the workpiece is in the high temperature. The tooling and handling is very risky one. The life of the tool used is also less. The tools, because it is directly working on the hot material, so the tool's life automatically it is reduced. So where we can start the rolling of metals. Rolling is the rapid method of forming metals into desired shape by plastic deformation in between rollers. So as the figure shows, there are two rollers, top and bottom rollers. The workpiece is heated to above the requisition temperature. When it is passed in between the two rollers rotate in the opposite direction. The metal is squeezed into a plastic state and its thickness is reduced, its length increased automatically. When it is comes out, the metal AV obtained a ricochet shape. The crystals are elongated in the direction of the rolling and they start to reform after leaving the zone of stress in hot rolling. The several parts can be produced in the hot rolling process. The T section, L section, the I section, the square section. There are so many models, workpieces shapes can be produced. According to the number of rolls, we can classify the rolling mills into different types. That is 2 high roll mill, 3 high roll mill, 4 high roll mill, cluster rolling mill, universal rolling mill and planetary rolling mills. All number of classifications are there. We can discuss one by one. So this is first section is the 2 high roll mill. So as the name implies, there are 2 rollers arranged in one over the above. The 2 rollers are rotates in the opposite direction as shown in the figure. If you want to work or reduce the workpiece in a particular size or particular thickness, the workpiece is heat to a high temperature, that is above requisition temperature. When it is inserted in between the 2 rolls, because of the rotation of the rolls, the workpiece is pulled in the direction of field. Then when the workpiece rolls in between the 2 rolls, it is squeezed because the workpiece is in the hot condition, nearly the plastic deformation occurs. Then it comes out as a thin workpiece with the extended length. Length may be extended. Here in the 2 high roll mill, both the hard working and cold working can be worked together, and by using the rolling mill, 2 workpieces, hot and cold working operation can be performed. In the latest section, the rotation of the rollers can be reversed also. At the same time, the distance gap between the 2 rollers can also be adjusted. By that, we can send the work the workpiece in the 2 direction also. That is the latest one. Then next is 3 high roll mill. As the name implies, there are 3 rollers are arranged one over the other. Refer the sketches. In this, the higher reduction can be possible in the same one rolling mill. When the workpiece is the gap between the upper and middle roll is more than the gap between the middle and lower rolls. Initially, the workpiece heated, the workpiece sent in between the top and middle rolls. The gap is adjusted. We can reduce the thickness of the workpiece. Then, when the workpiece comes out on the right hand side, we know that the gap between the upper and middle roll is more than the gap between lower and middle roll. Second, the workpiece sent in between through the middle and lower rollers. Again, it is thickness can be reduced. Here, the upper end roller mill rotates in the same direction. Middle roll rotates in the opposite direction. The rollers rotates by the action of the friction. The metal is reduced to our requirement. Then next is 4-high roll mill. There are 2 backing rollers available, 2 working rollers, small rollers are available. The backing rollers are on there's a bigger in size. The working rollers are smaller in size. The 2 big rollers are backing rollers. Why reduction is possible? Actually, the working rollers are small rolls. We can make more reduction by using the 4-high roll mill. Next is the cluster roll mill. Cluster roll means the number of rollers are arranged. Here, there are 6 rollers are arranged in this figure. There are 2 working rollers, 4 backing rollers, 2 on either side. Here also, the working rollers are the driving rollers. The big rollers are the backing rollers. 4 backing rollers, 2 working rollers. By using the cluster rolling also, the more reduction can be obtained. Next is the planetary rolling mill. See the figure. There are number of small rollers are arranged around the backing roller. Instead of the single small or 2 small rollers, number of wheels are fixed to the large backup roll. Here, because of the number of small rollers, very heavy reduction can be, large reduction can be obtained. Next is universal rolling mill. Universal rolling means there are vertical rolls and horizontal rolls are available. Vertical rolls and horizontal rolls are arranged in the sequence. Metal is reduced to a desired shape by both horizontal and vertical rolls. Vertical rolls are mounted either one side or both the sides of the horizontal mill. There are 2 or 3 or 4 horizontal mills are arranged. So here we show the I section formation. We can easily form the I section by using the universal rolling mill. The stages in shaping rules. Actually, we cannot obtain the desired shape, required shape in one pass or 2 passes. The number of passes, minimum 6 to 7 passes are required to obtain a finished project workpiece. Here we are showing that the I section is formed by using the 6 steps rolling mills. So initial section is the bloom is sent in between the 2 rollers. The bloom is obtained from the foundry shop. Actually, the foundry shop, they are producing the ingots. The ingots are larger in cross section. Then the ingots are reduced, size is reduced by using the 2-high roll mills. That is blooms or billets or slabs. We can produce it. The insert section, here the I section is formed by using the bloom. It is sent in between the rollers. A nearly one I shape is obtained, but with the enlargement of the ends. Then it is gradually step by step. Second stage, it is size is reduced to another level. The third step, the roughing of horizontal and vertical rolls are used. 2 rollers are used, vertical as well as horizontal rolls are used. So by that, the side extension, bulging is reduced, compressed by using the horizontal rolls. Then gradually it is reduced. The shape of the shape to be produced is made on the rollers itself. There are different rollers that are available according to or depends upon our requirement. Then in intermediate horizontal axle and vertical rolls are available. We are the fourth step we are performing it. Then fifth stage, the edging rollers. Edging operation is performed. The finally finishing horizontal and vertical rolls. By using the horizontal and vertical rolls, we are producing this I section is formed. So we cannot produce the record workpiece in a single pass. The number of series of operations are required to obtain the record shape. Next is by using the rollers, we can enlarge the ring. At the same time, the diameter can also be increased. The shaping process, by using roll shaping, it is called roll shaping. But here we are showing the ring rolling operation. The main roll is the power driven and the other rolls are supported. Here our purpose is a ring is available, thick ring is available. We have to enlarge the diameter, to increase the diameter, internal diameter. When we increase the internal diameter, as well as at the same time, the thickness also reduced. The outer diameter, inner diameter, the thickness also to be changed. The thin ring is expanded into a larger diameter ring with a reduced cross section. So cross sectional area will be reduced. There are two axial rolls are used, conical shape rolls are used. One main roll is used. Then main mantle is inserted in between the ring inner diameter. Then guide rolls. There are two guide rolls are on both the sides of the mantle. The ring is set like this. The ring thickness is reduced by bringing the rollers closer together as it rotates. With the reduction in the thickness, the ring diameter is increased. When the ring diameter increased, the thickness automatically reduced. It is in a short time. The close tolerance can be obtained. The materials are safe. There is no metal is removed. The metal is deformed into our record shape. That is comes under the ring rolling operation. Next is the thread rolling process. Thread rolling is actually the threads are formed at the lathes by removing the material, but here we are not going to remove any material. The metal is deformed plastically and we are impart the shape of the rollers on the workpiece. So it is a cold form. Normally it is a cold forming process. Straight and taper threads can be formed. Reciprocating dies are used. That is, one die is fixed, other one is reciprocating one. It is shown in the figure. No metal loss occurs. We are deforming the material. No metal is removed. Thread are rolled on metal of soft condition. Normally soft material remain copper like that. By bronze or copper threads are formed by using the thread rolling operation. There are different types of thread forming processes there. Flat dies can be used. The right side, the one die is in the stationary one, other one is the reciprocating one. Both the workpiece is placed in between the two dies. When the reciprocating die moves, the impressions present on the dies are impart on the workpiece. In the final stage, we obtain the threads. Then, instead of this flat die, the rolling dies also can be used. There are two rollers are available. The two rollers, the thread form is formed on the rollers. When the workpiece is inserted in between the two rollers, when the rollers rotate, the metal is squeezed, compressed, and the thread form is made on the workpiece. By using that, we are producing the threads on the workpiece. The working principle is shown in the figure. Another one is, instead of the vertical flat dies, there is a horizontal flat die. One is upper die, one is lower die. Normally one die is a fixed one, another one is the reciprocating one. By that we can produce the threads very quickly. Then next comes the tube rolling. There are two types of tubes are available. One is fabricated, another one is seamless. There is no fabrication. In the fabrication type, the metal sheet is folded into a round circular shape, then it is welded. Tack welding. Tack welding is done on the workpiece. We obtain the fabricated tube. Another one is the seamless tube. Seamless tubes are normally made by rolling process. Here the metal is heated, where we are using two conical rollers are used, as shown in the figure. We are passing the hot rolled billet in between the two rollers. When the two rollers rotate, the metal is drawn as well as rotates. To produce the hole, inner diameter, a mandrel is used. A sharp mandrel is fixed on the in between the two rollers. When the workpiece is passed between when it is pulled in between the two rollers, the piercing mantle pierces the metal and the inner diameter is formed. So with the help of the piercing and controlling size of bore as the billet is formed over it. Two piercing rollers which impart both the axial and rotational motion, we can obtain the rollers. We can obtain the seamless tube rolling can be obtained. There are various types of tube rollings are available. The fixed type mandrel or floating type mandrel by using the tab ties, that is the plugs is used. This is shown in the figure. The first is the fixed mandrel. By using the fixed mandrel, the internal diameter of the internal diameter of the tube is maintained or regularized. Internal as well as the external diameter of the tube is regularized in the finished workpiece. The moving mandrel also can be used. The mandrel is moved. The another one is the plug is used to size the workpiece. We can rectify all the problems which is created by fixed mandrel and the moving mandrel by using the plug rolling process. We obtain it correct sizing, outer diameter, inner diameter, size and shapes can be maintained in the plug rolling by tube rolling process. By using this, up to this we are discussing different types of rolling process by hot working metal forming process. Next class we will discuss about the cold working process. There are different types of cold workpieces are there. That is extrusion, the sheet metal working, cold rolling process, cup drawing process, different drawing processes are available, hot working processes are available, cold working processes are available. We will discuss this in the next class. So thank you one and all.